So we're kind of looking at some story problems today here. We already kind of did one to start class where we talked about compound interest. The problem we're going to work on right now actually involves the Richter scale and earthquakes. So this is problem number 18 on page 730. The intensity of an earthquake is described by a number on the Richter scale. The Richter scale number R of an earthquake is given by the following formula. So I have R equals log of A over T. This is not anything you'd have to memorize. It would be given to you if I would put this on a test. But you would just have to know how to plug in the numbers and be able to solve the equation. Where A is the amplitude of the vertical ground motion in microns, T is the period of the seismic waves in seconds. You guys should remember that period, is how long it takes to complete one wave, okay? And B is a factor that accounts for the weakening of the seismic waves. Obviously, the further you get away from the epicenter of an earthquake, those waves are going to get a little bit weaker because it's having to pass through the ground. Alright, so near the epicenter of the earthquake, there's going to be more destruction. It's going to be a stronger earthquake than when you're farther away. Okay? Alright, let's see how difficult these sort of problems are. It says, find the intensity of an earthquake to the nearest tenth if a recording station measured the amplitude as 200 microns and the period as 1.6 seconds and the B value of 4.2. Well, that's pretty straightforward. Aren't they giving us everything we need there?
Yeah.
Okay. So the R value will equal the logarithm of, what was the amplitude?
200 microns.
200 microns. T was the period, which was
1.6.
1.6 seconds. And B was the factor that accounts for the weakening of the seismic waves. Oops, so
4.2.
4.2. So those of you with the calculator real quick, please. Let's get that answer. Make sure you have parentheses around the 200 over the 1.6. We are using common logarithms, so that's good.
6.296.
So to the nearest
6.3.
tenth, 6.3. So that particular earthquake measured a 6.3 on the Richter scale. Right? You guys with me on that?
Yeah.
Okay. Alright. How much more intense is an earthquake with a magnitude of 5 on the Richter scale than an earthquake that measures a 4 on the Richter scale? Explain how you determined this result. How much stronger would an earthquake that measures a 5 on the Richter scale be than one that measures a 4? How many times stronger? How many times more intense? I want to take a shot?
10 maybe?
10. Yep. Okay. The answer over here is your exponent, right?
Yeah.
When you don't see a base, what is the base?
10.
10. So if I had a base of 10 and an exponent of 4 versus a base of 10 and an exponent of 5, how many times stronger is the one that has the exponent of 5? 10 times stronger, because 10 to the 4th is only 4 tens. 10 to the 5th would be 5 tens. So how many times stronger is the 10 to the 5th than a 10 to the 4th? 10 times stronger. Does that make sense? Okay. A Richter scale value is the exponent, okay, on a 10. So for every value you go up on the Richter scale, you're increasing by a power of 10. Okay. Okay? Alright. Let's see. What was the next one? 58? Okay, let's do that one. The altitude of an aircraft is in part affected by the outer air pressure and can be determined by the equation H equals negative 100/9 log of P over B, where H is the altitude in miles, P is the air pressure outside the aircraft, and B is the air pressure at sea level. Normally B equals 14.7 pounds per square inch. Suppose the air pressure outside the airplane is 10.3. What is the altitude of the plane? So again, that's just going to be pretty much plugging numbers in and getting the answer. That one's easy. B will take a little bit of work. We'll do A first though. So H equals negative 100/9 times the log. P in this case was 10.3. And B they're saying is 14.7. All you need to do there is find the altitude, which is in miles.
It's 1.7 something.
Looks like most of you are
I
getting
put
about
maybe
1.7
so
miles.
that's Just so silly. I thought you were that too.
Any questions on that first one? Next one. If the jet's altitude is 4.3 miles above sea level, what is the air pressure outside of the jet? So now how will that setup look?
Negative 100 over 9 log P over 14.7.
Equals how much?
4.3.
Very good. So now, our variable's in the logarithm, so we need to know how to solve for that variable. What do you think you guys would do here first, algebraically?
I'd say divide by the negative 100 over 9.
Divide by the negative 100 over 9, or multiply by negative 9 over 100.
Yeah.
Okay? A little bit of help on that.
Negative 0.387.
Negative point
387.
387, okay? Negative, and that's right on the money?
Yeah,
You didn't round that?
no
Okay.
more decimals in
Okay, so negative 0.387 equals the common logarithm of P over 14.7. Okay, then what do? You cannot, because that fraction is being logarithmed right now. What's the base?
10.
10, so not E, but let's use 10 and rewrite it in exponential form.
Good idea.
So it'd be 10 to the what power?
1. No, from P to the 3.87. Negative.
10 to the negative 3.87?
Yeah.
So 10 to the negative 0.387 has to equal how much?
P to the 14.
P over 14.7. Now get this answer using your calculator, then multiply both sides by 14.7. And tell me what you're getting.
6.03.
Okay? So if we go to the nearest hundredth, 6.03, and the label would be what? Air pressure's in, looks like PSI, right? Pounds per square inch. So about 6.03 6.03 PSI.
Okay.
Yes.
Question.
Yep.
On the 10, the one where we put the 10 in and put it to that power, how did that work?
What's this answer?
Is that? Well, wouldn't that be 2 then?
Yeah, why?
Because 4 squared is 16.
Perfect. Look, this base 4
Yeah.
has an exponent of 2, and that will equal 16. What's the base?
10
10. Would have what exponent? That number.
to get to
To equal that.
14.7. Okay.
That make sense?
Yeah.
Yep. It's the exact same thing, it's just with numbers that you just can't rattle off the top of your head. Does that make sense?
Yeah, it makes more sense.
That's all you're doing, is you're changing from a logarithm equation to the equivalent exponential equation. And by doing that, obviously, now we don't have a logarithm anymore. We can evaluate this on our calculator, then we can multiply both sides by 14.7 to get p by itself.
Yeah, that's better.
Okay, alright, good. Good question. Good question. What else? Okay.
4 and then 9.
Oh, I didn't take it times 14.7.
60 is a lot like the story problem we did at start of class. So what are those? On page 736 was one of the problems I gave you, number 60,
735.
or 735
Yeah.
was one of the problems, number 60.
Uh-huh.
Officially, it ends up, the problem itself ends up being on page 737. But I'm guessing that assignment started on page 735 maybe. But let's look at number 60. It talks about some chemistry stuff here.
Love it.
Alright. It says radium-226, which had been used for cancer treatment, and this book is old, so who knows if it is still used. Alright. Decays with a half-life of 1,622 years. Okay? 1,622 years. So, knowing that, it says find the constant K using 1 gram as the original amount of radium-226. So, this is making an assumption you know the formula here for it, which I need to go find for you, I guess now.
I didn't know, and then I did know, and now I don't know.
Yep, that's how I was. I had to learn on my own. And I was like,